Hi everyone! In today's video we will do another data science project together. If you don't know me, I'm Karina, I'm finance person turned data analyst turned data scientist. Today we will build a customer segmentation model using k-means algorithm. I found the data I will be using in this project at kaggle.com, link to the data in the description. K-means is a popular clustering algorithm used in machine learning and data mining to partition a dataset into k-distinct non-overlapping subsets known as clusters. The goal is to categorize data into clusters, such that the points within the same cluster are more similar to each other than to those data points in other clusters. It is a type of unsupervised learning algorithm. And let's briefly talk about difference between unsupervised and supervised learning algorithms. Supervised learning algorithms learn from the labeled data. So the input data is paired with the correct output data. The goal of supervised learning is to learn from input data and make predictions on new unseen data. Examples of supervised learnings are classification and regression. Classification is predicting categorical labels, such as detecting spam emails or image recognition, or predicting whether a loan will be approved or denied, the project which we've done in the previous episode. And regression is predicting a continuous values, for example, predicting stock market trends or house pricing. Examples of supervised learning are logistic and linear regression, SVM or support vector machines, decision trees, random forest, and neural networks. Unsupervised learning algorithms learn from unlabeled data, where the algorithm tries to identify patterns and structures without any specific output labels. The objective is to find hidden patterns or structures in the input data. The examples of unsupervised learning is clustering and dimensionality reduction. Clustering is grouping similar data points together, and that's exactly what we will be working on today. It can be customer segmentation or document clustering. And dimensionality reduction is reducing the number of features while preserving the essential information. And the examples are principal component analysis and TSNE, which is T-distributed stochastic neighbor embedding. The examples of unsupervised machine learning algorithms are k-means and hierarchical clustering, DB-scan, PCA, and TSNE. And as I said, applications of k-means, for example, document clustering, when you organize a large collection of documents into clusters for easier analysis and data retrieval. Or a customer segmentation, when you group customers based on a similar behavior for marketing purposes. Another example is image compression, when you reduce the number of colors by clustering pixel colors. And the last one, anomaly detection, identifying unusual patterns in data by clustering normal behavior and detecting outliers. Okay, let's build our algorithm. We will start with reading our file, and to read the file I will use pandas. So if you never used pandas before, you need to install this library. We do it with exclamation mark, pip install pandas. And then you need to run this code. Then we need to import our pandas library. Import pandas spd. And next step, we read our file. So we create in a new data frame df equals pd, which is pandas dot read underscore csv brackets, and in brackets we need to indicate the path to our file. I just pasted because I don't remember. And let's print a 5 top rows with df.head brackets. Let's run this. Okay, so our dataset has 5 columns: customer ID, gender, age, annual income, and spending score. Let's check summary statistics with .describe brackets. So we do df.describe brackets. Run it. So what do we see? We can see that age of customers range from 18 to 70 years. Annual income ranges from 15,000 to 137,000. And the spending scores, they vary from 1 to 99. The next step, let's check if we have any missing values in our data. So we do df.isNull brackets .sum brackets. Okay, we don't have any missing values in this data. And the last step, let's see the basic information, number of rows, and what data types we have with df.info brackets. Okay, so we have only 200 entries, and data type, so gender is object, the rest is integer. I again used a small data set for the purpose of this video, but you can find other data sets, apply everything you learned in this video, and add this project to your portfolio. So our dataset includes both numeric and categorical data, where gender is categorical data, which is female, male, and the customer ID, age, annual income, and spending score is a numeric data. The next step, I will change names of two columns of annual income and spending score. I don't like that it has brackets and this from 1 to 100. It will be annoying to type it over and over again, so I will change names of these two columns. To do that, we will use rename. So df.rename brackets, then we say columns equal and curly brackets. And curly brackets because we're using a dictionary. So I'm showing what I want to change to what I want to change. So annual income original name, I want to change to annual income like this, comma, I want to change spending score, colon, to spending score. So I don't want to have any spaces. After the curly bracket, we say comma, in place, equals true. And let's see how our new data frame looks like. Those two columns were renamed. Let's visualize the key features. For clustering, we will focus on annual income and spending score, and also then I will do gender and spending score, and then we will use 3 of those features together and build 3D graph. So we will start with a Pairplot that shows the relationship between age, annual income, and spending score. That helps to visualize how these features interact with each other. For our visualization, we will use 2 libraries, matplotlib and seaborn. We need to import Pairplot from matplotlib library. That's why we say import matplotlib.pyplot as plt. And then we need to import seaborn. I will remind again that if you don't have these libraries imported, you need to first run pip install matplotlib and pip install seaborn. Let's see that there is no errors, all good. And let's build our Pairplot. Pairplot lives in seaborn libraries. We say cns.pairplot brackets, and in the brackets we say which columns we use. At first we indicate the name of our data frame, which is df, then twice we say square brackets, and then we say 3 columns. So we use age, we will use age, annual income, and spending score. And we need to say plt show to display our graph. So plt.show brackets. Okay, this is how our Pairplot looks like. Interesting, already here in annual income and spending score, you see several clusters. I can see 5 clusters. So you see data points are grouped together. And also spending score and age, I probably see maybe 3 clusters, maybe 4, but let's analyze it in more details. So we will create a scatter plot, the plot of annual income and spending score, and potentially it will reveal groupings or clusters visually. As always, we start with selecting the figure size. So plt.figure brackets figure size equals, and I will do 10 by 6. Then I'm selecting which features I will be displaying. So plt.scatter brackets, and then we say df because we need to reference to our data frame, brackets annual income, df brackets spending score, comma s equals 50. S equals 50 is a parameter that sets the size of the scatter plot markers or dots. Each marker will have a size of 50. And now let's add the title and labels x label and y label. So plt x label brackets, and it will be annual income, plt y label, it will be our spending score, title is plt.title, it will be annual income versus spending score. And now we need to display our visual with plt.show. Okay, as I said, I can see 5 distinct clusters. So 1, 2, 3, 4, and 5. All right, so now let's apply our k-mean algorithm to segment the customers based on their annual income and spending score. But initially we need to use a technique called elbow method to determine the optimal number of clusters. The goal is to find the number of clusters where adding a new cluster doesn't provide much better modeling of the data. This is visually identified as an elbow point in the plot of within cluster sum of squares and the number of clusters. In k-means, k is the number of clusters. Advantages of this elbow method: it is simple and intuitive method to determine the number of clusters. It helps to avoid overfitting by not choosing too many clusters, but the limitations are that elbow point might not always be very clear or well defined, especially in a dataset where decrease and within cluster sum of squares is gradual. And another limitation, this method might not work for all datasets or clustering scenarios. So the steps of elbow method: first, we fit k-means for a range of a cluster number. So we run the k-means algorithm on a dataset for different values of k, for different number of clusters, and usually it's from 1 to 10. We run this algorithm over and over again, changing number of clusters, number of k. Then you calculate within cluster sum of squares for each of those clusters, and then we need to plot within cluster sum of squares versus number of clusters. Then we identify the elbow point or the optimal number of clusters. First of all, we need to import k-means from sklearn library. What we do, we say from sklearn.cluster import k-means, km. Now we need to select features for our clustering. X equals df square brackets and another square brackets. It will be annual income, comma, spending score. And now we need to determine the optimal number of clusters. We will create an empty list, which is within cluster sum of squares, or VCSS equals square brackets, and it's empty. And then we will create a loop to run our algorithm for number of clusters from 1 to 10. Create a loop in Python. You say for I in range, then you select the range. We want to run it for k equals 1 to k equals 10. That's why you say for range from 1 to 11, 1 comma 11. At the end of the loops in Python, you always use colon. Now we're creating our k-means equals k-means what we've just imported from sklearn library, brackets, number of clusters. In this case, we will be equal I because we want to run it from 1 to 10, as I said before. Init equals k-means plus plus. I will explain all the parameters now. Max iteration equals 300. Then we are fitting our model with k-means.fit X, and we need to append the results over and over again to our empty list which we've just created. So vcss.append k-means.inertia. Let's run it. No errors. Let's talk about each parameters. Init method is a method used for initializing centroids or central points of our clusters, and k-means plus plus being a common choice for better performance. Max iteration is the maximum number of iterations for a single run. So if the algorithm doesn't converge before reaching 300 iterations, it will stop. In most cases, the algorithm converges well before reaching this limit. N_init equals 10 is the number of times the algorithm is run with different initializations. Choose the best result. And random equals 0 is the parameter that sets the seed of the random number generator. Setting a random state ensures that the results are reproducible. Spoke about it in the previous video. So you can pick any number you want. Usually people select 0, 1 or 42. When you use the same data set, the same random state, you will get exactly the same results. Okay, so now calculations is done and we need to create a plot. We need to plot our within cluster sum of squares versus number of clusters to identify this optimal number of clusters. As usual, when we're creating our plot, we start with selecting the figure size. oplt.figure brackets fig size equals 10 by 6. Then we need to say what we are plotting, number of clusters versus within cluster sum of squares. So what we will do range from 1 to 11, comma, within cluster sum of squares. We need to add our labels and titles. So plt x label will be number of clusters, and our y label will be within a cluster sum of squares. And our PLT title will be elbow method to determine optimal number of clusters. And let's display our visual with plt.show, run. Okay, you can see that optimal number of clusters is 5. It is this point, this elbow point. Now we will again run our k-means algorithm as we've done before. So this line of code, but number of clusters will be 5. So we can copy our line of code. We will change number of clusters I to 5. Now let's create a new variable called y underscore k-means equals will be k-means dot fit underscore predict our x variable. Let's run it. So our k-means algorithm is done. And now let's add the labels produced by this model back to the original data. So we will create a new column in our df data frame. So we'll say df square brackets, new column, we will call it cluster, equals our variable y underscore k-means. Let's run it and let's run df.head to see how our data looks. So that's our original data frame, but now we have a new column called cluster. So now we can see to which cluster each of the customers belong to. So we can see customer ID 1 belongs to cluster 3, customer 2 belongs to cluster 4, etc. Finally, let's visualize our clusters and their boundaries. I will copy prepared lines of code and explain you what is happening here. So the first line of code is we're setting figure size as always. Then we are creating our scatter plot. And to create a scatter plot, we use .scatter. What is x.ilog? When we use ilog in the brackets, the first part before comma, it's selecting rows. The second part after comma is selecting columns. With our example of x.ilog square brackets, we have a semicolon, meaning we're selecting all the rows. And where do we select it? In the very first column or column number 0. As you know, in Python, indexing starts with 0. This parameter selects all the rows of the first column of the data frame x, and these values are used for our x coordinates in the scatter plot. And then we select what will be used for our y coordinates. So we will use all the rows from our data frame x, which located in the second column, or in a column equals 1. C equals y underscore k-means that set the color of the points. Y k-means contains the cluster labels assigned by the k-means algorithm. S equals 50, as we spoke before, it set the size of the points in the scatter plot to 50. And as the last part, we are selecting colors of our visual. So I pick this viridis, it's color gradient ranging from purple to yellow. So this line of code or cent, this is that retrieves the coordinates of the cluster centers found by the k-means algorithm. And centers is an array where each row represents the coordinates of the cluster center. Now let's talk about the next line of code. Again, it is for our scatter plot. We're creating another scatter plot, this time for cluster centers, where centers, again, we're selecting at first x coordinates for our clusters, all the rows in the very first column, then all the rows in the second column for our y coordinates. C equals red, we set the color of the cluster centers to red, so it's more visual. With our s equal 200, we set the size of the points representing the cluster center to 200, so they're more visual. Alpha equals 0.75. Select the transparency in this case of a cluster centers. It means that 75% will be opaque and 25% transparent. And marker equals x. It sets the marker style to x, meaning the cluster centers will be represented in an x space, and you will see it now. Let's run. Here we are. So you see I made this visual more colorful so we can clearly see all our clusters and their centers. So we have 5 clusters, and that's where their centers are located. So when we look at those clusters, each cluster can be interpreted as a different segment of customers based on their annual income and spending score. So let's have a look at this first cluster where it's a low spending score and low income, or this green cluster. Low annual income, low spending score, and these customers might be budget conscious or infrequent shoppers. Our next cluster will be yellow cluster, so it's a low annual income, but it is a high spending score. This could be younger customers or individuals who prioritize spending on certain occasions despite having a lower income. Then we have our middle cluster. It is customers with moderate annual income and moderate spending scores. And interpretation, probably average customers who have balanced spending habits. Let's have a look at cluster number 4, customers with high annual income but low spending score. So this is, I assume it's a teal color. We would say that it is wealthier customers who might not spend much, possibly because they save money or shop somewhere. And our big spenders, the last cluster, they have high spending score and high annual income. It's our premium customers who are likely frequent shoppers and spend a lot on luxury and high-end products. So what business insights can we get from this analysis? So each cluster represents a unique customer segment that can be targeted with tailored marketing strategies. I personally did a project like that for a fashion retail where they wanted to segment customers, and those big spenders, big spending score, big annual income, it is your VIP customers. They have special treatments. They have the first one who have access to special discounts, promotions, and events. So in our case, for example, promotions for budget-friendly products can be directed to cluster 1, while premium products offers can be targeted to cluster 5. This type of analysis also helps with customer retention, because now you understand the characteristics of each cluster, and it might help you to create the strategy to retain those high-value customers in a cluster 5 and convert low-spending customers, which is cluster 1 and cluster 4, into high spenders. For our K-means, we pick 2 features, which is a spending score and annual income, but you can also create K-means for age and spending score. So let's do those steps. It will be very similar, but at the very beginning, we will just pick different features this time. Let's create the initial scatter plot, how we did for our annual income versus income score. I will completely copy all the code and just change one feature. So in the annual income, this time we change it to age. Let's run it. This is where I see probably 2-3 clusters, definitely 1 and 2, but there might be 3 or 4. So let's do our K-means. We will do exactly the same steps as we've done before. We'll start with selecting features for clustering and doing our elbow method. So not to bore you to death, I will just copy all the code. Okay, this is the elbow method to determine optimal number of clusters for 2 features, age and spending score. And this time I would say we have 4 clusters. So this time I added cluster labels to the original data and I called this column cluster age. So let's have a look at our data frame. So it's df head, and you can see we have the column cluster. It's from our previous K-means when we were comparing annual income to spending score, and this time we're creating clusters based on age versus spending score. For example, our customer 2 is in a cluster number 4 based on our previous analysis, and in a cluster number 1 based on our current analysis where we compare age and a spending score. And now let's visualize our new data. And here we can see our 4 clusters. So our first cluster is people from 20 to 40-year-old, and they're big spenders. Then we have moderate spenders who are also aged from 20 to 40. Then we have more mature customers aged from 50 to 70. They are moderate spenders. And we have the 4th cluster, which is spread across different ages, but they are low spenders. So what are the pros of clustering on age and spending score? First of all, we can understand the behavioral insights by age group. So this approach can provide insights into how different age groups spend. For example, we can discover that younger customers have different spending patterns compared to older customers. And with targeted marketing, it helps in creating age-specific marketing strategies. You can tailor marketing campaigns to the preferences and spending habits of different age groups. So I assume you can use different types of marketing. I mean, maybe Facebook advertising works better for older customers, TikTok advertising works better for younger customers. For more comprehensive understanding, we can consider combining both approaches. So we will use all three features: age, spending score, and annual income. In this case, we will have to create a 3D graph because we have three features. So actually, steps for creating k-means will be exactly the same. I will again copy the whole algorithm, but this time we have three features. So when we're creating our x variable, we're using age, annual income, and spending score. To determine our optimal number of clusters, we use again our elbow method, and nothing changes. It's exactly the same as in previous two examples. And then we need to plot the elbow graph, again exactly the same process. I would say that in this example, I think the optimal number of clusters is actually 6. So let's run our k-means using k equals 6. And again, we will add results as a new column to our data frame. So I will call it cluster age, income, spend. And the last step, we need to create a 3D graph. To create a 3D graph, I will be using Axis 3D. So from the library called mpl_toolkits.mplot3d, we need to import Axis 3D. Then, as usual, we need to set the figure. This time I will set from 10 to 7. The next line, we add in a 3D subplot. 111 in this case means that one row, one column, first and only subplot. And projection 3D specifies that the subplot should be a 3D plot. The next line of code is a scatter plot. So we're selecting X, Y, and Z axis. So C equals df cluster age, income, spend. This is the column we just added, and this sets the color of the points. S equals 50, the size of the points in the scatter plot, and I'm selecting the color map, and again I picked Viridis. Then we are setting again labels for X label, Y label, and Z label, and creating title, and of course plt.show to display the visual. And here we are, and this way we created this 3D graph to see our clusters. I hope you found this video useful. Please let me know in the comments if you want me to create more projects like that. Also, let me know if you're more interested in data science or data analytics projects. Please don't forget to click like and subscribe button, and I hope to see you next time.